Hello everyone, this is Nafees Hassan Chowdhury and I'll be presenting my foundation computing presentation to you. And these are my contents. So let us get introduced to what is a computer. A computer is a machine that can be programmed to carry out sequences of arithmetic or logical operations automatically. Modern computers can perform generic sets of operations known as programs. Let's move on to topic 2.1. Identify internal components of a central processing unit. So basically there are 5 components of central processing unit, which are arithmetic logic unit, instruction register and pointer, cache, memory management unit, CPU, clock and control unit, and random access memory, which is known as RAM. So now let's move on to topic 2.2. Explain the functions of a CPU. So here I've presented the function of CPU in 4 steps, which are: the CPU receives the data when the computer inputs the data through input devices such as keyboard or mouse. Number 2, after this, the CPU processes these input data by performing calculations and technical algorithm. Number 3, and then CPU provides the processed data through an output device such as on the monitor screen. Number 4, the CPU also stores the processed data in the form of a cache for future use. So here is basically a diagram of functions of a CPU. Let's move on to number 2.3. How here to explain that how computer hardware components work together. A computer is a machine composed of hardware and software components. A computer receives data through an input unit based on the instructions it is given, and after it processes the data, it sends it back through an output device. The main components of a computer are CPU, RAM, HDD, motherboard, video and sound cards, and the last one is network adapter. So after finishing this, let's move on to number 2.4, which helps us to identify different types of storage media and explain the use of each with reference to the purpose. The storage device is one of the basic elements of a computer device. It also saves all data and applications in a computer except for hardware firmware. It comes in different shapes and sizes depending on the needs and functionalities. These are some of the storage devices. Let's move on to 3.1, which explains how data is represented in computer system. Computers represent data in sets of binary digits. The representation is composed of bits, which in turn are grouped into larger sets such as bytes. A binary digit or bit is the smallest unit of data in computing. It is represented by a 0 or a 1. Binary numbers are made of binary digits. Example, the binary number 1001. All software, music, documents, and any other information that is processed by a computer is also stored using binary. Next, we'll explain how encryption can be used to represent data. Data encryption translates data into another form or code so that only people with access to a secret key or password can read it. Encrypted data is commonly referred to as ciphertext, while unscripted data is called plain text. Currently, encryption is one of the most popular and effective data security methods used by organizations. There are two main types of data encryption that exist. One is asymmetrical encryption, which is public key encryption, and two is symmetric encryption. After this, let's describe how images and sounds are represented in computer systems. There are two types. First is representing image. Images also need to be converted into binary in order for a computer to process them so that they can be seen on our screen. Digital images are made of pixels. Each pixel in an image is made of binary numbers. Second, representing sound. Sound needs to be converted into binary for computers to be able to process it. To do this, sound is captured usually by a microphone and then converted into a digital signal. Next, let's see how compression can aid the storage of data, images, or sounds. The purpose of compression is to make a file, a message, or any other chunk of data smaller. Data compression can significantly decrease the amount of storage space a file takes up. If we had a 10 MB file and could shrink it down to 5 MB, which is megabyte, we have to compress it with a compression ratio of 2. Since it is half the size of the original file, if we compress the 10 MB file to 1 MB, it would have a compression ratio of 10 because the new file is a tenth the size of the original. The higher the compression ratio, the better the compression. Let's move on to 3.5, which describes the purpose of a logic gate. Logic gates are theoretical or practical circuits that make an electronic logic operation possible. In a digital device, logic gates receive single or multiple binary inputs and transform them into single binary output. Purpose of logic gates are mentioned below. First, logic gates are used as building blocks of digital electronic hardware. Second, logic gates are used in the construction of simple comparator. Third, logic gates are used for decision making. Fourth, it is used in constructing alarms. 5. It is used in push button lock circuits. 6. It is used in traffic light. Now let's move on to 4.1, which describes the purpose of different types of computer network. There are basically two types of network, which are LAN and WAN. Here are different types of computer networks. wide area network, local area network, metropolitan area network, campus area network, and home area network. Let's move on to 4.2. It describes the hardware, software, and transmission media used in computer networks. The software components are operating system and protocols, server, clients, networking, operating system. So let's move on to 2.3, which helps us to identify a range of World Wide Web technologies. HTML stands for Hypertext Markup Language. It is the standard markup language for web pages. HTML elements are the building blocks of HTML pages. HTML elements are represented by tags. 4.4 describes the purpose of different types of computer network topology. First, bus topology. Second, ring topology. Third, star topology. Fourth, mesh topology. And fifth is the tree topology. Here are different types of, here are the diagrams of different types of topology. Thank you.